So the question is, why should you measure total chlorine, free chlorine, and ORP? So here we can see total chlorine is the combined chlorine with junks plus free chlorine. It means that when you are adding a chlorine in water, some part of this chlorine is going to combine with junks in water, which is not effective. And the rest of the chlorine, we call it free chlorine, it shows the disinfection potential. So this is really important for us. So that's why total chlorine should be 8 to 10 ppm. But looking at the free chlorine, which we said it is the part that is going to really disinfect water, it is a combination of hypochlorous acid, which is the HOCl, and also hypochlorite ion, which is the OCl. Okay, so this acid form of free chlorine, we would call it strong guy. Strong guy means that it's going to really disinfect water and it has that potential. But the ion part is weak guy. It means that it has weaker disinfection potential. So which one we like? Of course, the acid form, which is the strong guy. So free chlorine overall should be between 3 to 6 ppm. Again, free chlorine is the combination of acid form and ion form, with strong guy plus weak guy. So looking at the pH, water pH, you can see if we have lower pH like 5.5, 6, 6.5, in that case, you can see the concentration of acid form is high, which is the strong guy. But as water pH goes up to 7.5, 8, 8.5, you can see the concentration of acid form, which is the strong guy, is dropping, which is not good. So that's why chlorine is effective in lower pH. And that's why we said if your water pH is above 7, then you need to use inorganic acid or mineral acid to lower the pH to, under 7, and then inject chlorine to be effective, to have more of acid form or strong guy to disinfect water. And ORP, or oxidation reduction potential, shows the strong guy. It means that if your ORP is above 650 millivolt, it shows that the concentration of acid form or strong guy is high, which is good. So that's why we need to measure all of them. And as your free chlorine level is closer to total chlorine level, it shows that this combined chlorine with junks is low. It means that most of the chlorine, injected chlorine into your water system, is actually free chlorine and it's going to work. And from that free chlorine, if you have more acid form, more of acid form or strong guy, is better, which is going to be proven by ORP level. If your ORP level is above 650 millivolt, it shows that your acid form is higher. So now, how much chlorine is needed to start disinfection? This is the question we are receiving all the times. So again, to answer this question, we need to have a look at the breakpoint of chlorination curve. So what is breakpoint? So just to simply look at the breakpoint here, just have a look at the amount of chlorine added into a water system. We are going to inject chlorine. As you can see, as we are injecting more chlorine into the water line, the concentration of chlorine is going up, right? So here is the chlorine residuals. So as we are injecting more chlorine into the water line, the concentration of chlorine residuals is going up. But after a point, we can see a decline in the chlorine residuals because so far, whatever chlorine we have added, it is combined with junks, which we don't like it because it's like waste of chlorine. So, but after reduction of residuals at a break point, we can see again as we are adding more chlorine, the chlorine residuals concentration is going up. So if we, draw a line here, from the breakpoint, we can see from here all the way to here is the combined residuals, which we don't like it, which is not effective. But from the breakpoint, I mean above the breakpoint, it is the free residuals or free chlorine, which we like it because it's going to really have that disinfection role. So breakpoint, I would say, is the point where after that, whatever chlorine we are adding into the water is effective. Effective in terms of disinfecting the water system. So now it makes sense to shift the curve into the left side. It means that by adding less chlorine, we should reach the breakpoint earlier, faster, and by that, we are using the chlorine more efficiently, right? So how should we do? So the question is, how should we really shift the breakpoint to the left side or to increase chlorine efficiency? So there are some factors. The first factor is contact time or CT value. I'm going to talk about that in the next slide. Water temperature should be above 19 degrees centigrade. It means that if the water is cold, is like colder than 19 degrees centigrade, in that case, chlorine is not really efficient. And concentration of ammonia and chlorine is important in the water. Wherever you have high concentration of ammonia, it's going to eat up your chlorine or waste your chlorine. That's why it's a good idea to keep the ammonia low. And pH, because if, as I showed in that previous curve, if the water pH is high, then chlorine is not effective because the ion form is high, which is the weak guy, and we talked about that. So just quickly talking about CT factor. CT is the multiplication of concentration of free chlorine by time. So it should be 8. The optimum CT value is 8. So let's say your free chlorine residuals is 1. If your contact time is 8 minutes, then you're going to get a CT of 8. It means that if your chlorine residuals is 1 ppm, you need to mix it with water and sit at least for 8 minutes in the tank, mixing tank, to reach a CT of 8. But let's say if your free chlorine residuals is 4 ppm, then you need only 2 minutes contact time in the mixing tank to reach the CT of 8 to be effective. So overall, keep in mind, chlorine is a good sanitizer. It is cheap only if water pH is between 4 and 7. If your water pH is above 7, you need to lower it by using acids. And as I mentioned, it should be inorganic acid or mineral acid. The water organic matter should be low, and water temperature should be above 18.9 degrees centigrade to be effective. So some people say, okay, when I'm injecting chlorine into my water, let's say water is coming from well and it is cold. Let's say it is 3 degrees, 4 degrees centigrade. Is it effective? At that point, no, but this water, when you injected the chlorine, it's going to travel inside the barn, and of course the temperature inside the barn is high. It's going to warm up the water, and as the temperature goes above 19 degrees centigrade, the chlorine will start to be more effective. So don't worry about that. If the water temperature at the injection point of chlorine is low, don't worry about that. And water should have low turbidity or less cloudy. These water samples you can see here, they are cloudy, which is not good. It's going to eat up your chlorine, and by that, chlorine addition will not be efficient. And try to use fresh chlorine product and good storage. Don't store them under sunshine, because otherwise its efficiency will drop significantly. And enough exposure time, we talked about this, which is the multiplication of concentration of free chlorine by time. It should be at least 8. And remember, always measure total chlorine, free chlorine, and ORP, or oxidation reduction potential. And we talked about this previously. So just to wrap up this session, just an example, a practice. Let's say here is our water line in the barn. So the concentration of free chlorine at the beginning and also at the end of the line for scenario A is 5 ppm and 3 ppm. For scenario B is 5 ppm and 1 ppm. And for scenario C or farm C is 5 ppm and 0 ppm. So the question is, which line is cleaner? You are adding chlorine into the water line, into these 3 water lines. And as you can see, the initial ppm is the same, 5 ppm for all of them. But at the end of the water line, for water line A, it is 3 ppm. For water line B, it is 1 ppm. But for the water line C is 0 ppm free chlorine. So which line is cleaner? I'm going to let you guess, and not only guess, you need to justify it. Which line, which water line is cleaner? Post your answer down there in the comments area, and I will reply to your answer. So, to answer this question, try to have a deeper look at chlorine chemistry and what we discussed just over the last few slides. I hope this is helpful. I know it's a bit overwhelming, but it is important because overall, specifically during disease outbreak, we need to have strategic water treatment practices in place. So again, please let me know down there in the comment which line was cleaner, line A, B, or C, and I'll see you in the next episode. Take care.